Hello everyone, my name is Dinakar Nethi and I'm a product manager in the Azure data team. I'm focusing on Azure-Arc data services, which is going to be the topic for today's session. Please note that this topic is spread over 2 sessions, so please make sure to attend both the sessions. In session 1, we will cover the general concepts of Azure-Arc, the various offerings that we have within the Azure-Arc brand, the general capabilities across these offerings, and then we will deep dive into Azure-Arc data services. Within the data services topic, we will look at what is Azure-Arc Data Controller, what are the benefits it brings, and we will do a short demo on how to deploy Azure-Arc Data Controller from tools like Azure Portal, Azure Data Studio, or even command line. Then we will move on to Azure-Arc enabled SQL MI. We will look at the various benefits of Arc SQL MI. We will also deploy Arc SQL MI from Portal, Azure Data Studio, or kubectl. And then we will take a look at TCO, benefits for migrating to Arc SQL MI. And finally, we will finish up with a roadmap of what is available today for you to try and some resources to help you get started. In session 2, we will go really in depth into each of these business continuity capabilities, such as high availability, point-in-time restore, disaster recovery, monitoring, security upgrades, etc. And then we will finish up with a roadmap again. And with that, let's get started. To give you some context, in the last 5 years or so, customers' environments have become increasingly complex with hundreds of applications, virtual machines, container services, with all kinds of technologies between legacy applications to modern cloud-native architectures. The infrastructure has also evolved from being mostly either on-premises or cloud to hybrid and even multi-cloud architectures. Multi-cloud and hybrid architectures has become more or less the standard these days. All this sounds cool when you draw the solution on a whiteboard, explain it to someone, or put it on a PowerPoint. However, this complex design also brings some challenges with it. Things like, how do you ensure security across all these workloads and different environments? How do you govern and operate across your workloads in a consistent manner when the workloads could be running in your on-premises and cloud providers such as Microsoft Azure, AWS, or GCP? At Microsoft, we are attempting to solve this customer's challenge via Azure-Arc. Azure-Arc provides a single pane of glass to view and manage your inventory across environments such as on-premises, Azure, AWS, GCP, or any other cloud provider. Customers can use familiar set of technologies, tools such as Azure Portal, Azure CLI, or even Azure Data Studio to view and manage your resources regardless of where they run. Moving on. You can think of Azure-Arc as a brand under which we have different types of offerings, broadly categorized into 2 models. First one is the infrastructure model, and second one is the services model. You can think of infrastructure model as equivalent to infrastructure as a service model, where you continue to own and manage the resources or workloads and get some benefits from Azure. Services model is similar to platform as a service model in Azure, where you get a lot more benefits from the provider. Let's look at each of these in detail. There are 3 offerings under the Azure-Arc enabled infrastructure category. First one is the Azure-Arc enabled servers. Second one is Azure-Arc enabled SQL servers. And finally, the Azure-Arc enabled Kubernetes. In the Azure-Arc enabled SQL servers, in the Azure-Arc enabled servers offering, we have some virtual machines or physical servers that are running different operating systems like Windows, Linux, Red Hat, etc. And they could be either on-premises or in a different cloud, maybe GCP or AWS or even a private hoster. You install an Arc agent on this VM, and that agent will project this VM into Azure as an Arc resource. And then from Azure Portal, you can view and manage this resource that is running outside of Azure as if it is running in Azure. This pattern continues with the other two offerings as well. So in the Arc-enabled SQL Server model, you have a VM or a virtual or a physical server, and it could be running either Windows or Linux operating system, and you have one or more SQL Server instances that are running on that host. You install this Arc agent on the same VM or same host, and that agent will project these SQL instances into Azure as Arc resources. And then once they're in Azure, or once they show up in Azure portal, you can view and manage them from Azure portal as if they're running in Azure, even though they're running outside of Azure. The same pattern continues for Arc-enabled Kubernetes as well. So you have your Kubernetes cluster that's running either on premises or in a different cloud. You install the Arc agent. Agent does its job, projects the Kubernetes cluster into Azure. Then you manage that Kubernetes cluster from Azure as if it's running in Azure. The second category of offerings, which is the platform as a service model. In this model, we have Azure-Arc enabled data services. Within the data services, we have two database engines that we offer today, SQL Managed Instance and PostgreSQL Server. These data services can be deployed in either connected mode or disconnected mode. And I will go into details shortly in one of the next few slides. The idea with this platform as a service model is that you need to migrate your data from your existing SQL Server, wherever it's running, into this Arc-enabled SQL Managed Instance, and you get a lot of benefits from the platform, which will greatly improve your productivity. First, you get an evergreen version of SQL instance, just like what we have in Azure SQL. It is not a fixed version like what you have on premises, which means you get continuous updates via monthly releases, and this update includes both security as well as feature updates. Since it's not a fixed version, you don't have to worry about upgrading to the next major version or support cycles like mainstream support, extended support, etc. You simply get the latest and greatest all the time. Then you have the as a service capabilities, such as, go back. As a service capabilities such as elasticity, meaning you can deploy in seconds, you can scale up or scale down with a single command. You have built-in high availability. You have built-in backup service, which will allow you to do point-in-time restores. You have built-in monitoring, built-in logging, etc. You can also configure additional Azure services, such as Azure Defender or Azure RBAC, Azure Policies, etc. on these resources that are running outside of Azure. Since this is an Azure branded service, the billing model is also similar to cloud-based billing, meaning you can scale up or down on your business as your business needs change, and you only pay for what you consume. Finally, bringing all this together is the unified management view. This means you have a single pane of glass, which is the Azure portal, to view and manage all your resources, whether they're running in Azure or outside of Azure, such as your on-premises or even in a different cloud. And you can use the same familiar tools like AZCLI, Azure Portal, Azure Data Studio to view and manage these resources. Moving on. Just to give you a comparison of the workloads in and outside of Azure here, the workloads above the red dotted line in the middle of the slide here are the workloads that are available or running in Azure. And the workloads below the red dotted line are Azure equivalent workloads that are running outside of Azure. For instance, the Arc-enabled SQL Server is equivalent or similar to SQL Server in Azure VM, where you install the SQL Server, you manage it, you take care of it. Moving on to the right, you have Arc SQL MI, which is outside of Azure, and you can think of it as equivalent to the Azure SQL MI, which runs in Azure in terms of benefits, right? And the same goes for PostgreSQL as well. Moving on to customer scenarios. So what sort of workloads would benefit from Arc-enabled data services, right? The typical use cases would be customers have their own data centers where the workloads run, and in addition to a cloud provider. Customers have strategic agreements with say multiple cloud vendors, so they have the need to run their workloads in different clouds. By using Azure-Arc, they can use a consistent set of deployment and management policies and achieve PaaS-like benefits regardless of which cloud they run on. Another use case is the need to operate databases in factories in edge locations in addition to on-premises data centers or other clouds. Or sometimes even government regulations require that data does not leave the country. And if there is no Azure region within the country, customers are either running their workloads in their own data centers or different providers if they have data center within the country. In all these scenarios, the fundamental model is the same. You have your database workloads that cannot move to Azure for whatever reason, right? You have your own data center, there's no Azure region, you have a reason to run in a different cloud, doesn't matter. You just don't have the option to move to Azure. So with Microsoft's Azure-Arc, we are attempting to bring Azure to you via Azure-Arc, either through Arc-enabled SQL servers or through Arc-enabled data services. Moving on. So we have Azure services that run in Azure and Azure branded services that run outside of Azure. And this brings the question of roles and responsibilities and expectations from customers, right? In Azure, Microsoft owns and manages the entire vertical stack from hardware to the networking to computing, storage, all the software that runs on top of this infrastructure. Hence, Microsoft is in charge and responsible for all these services, and we can guarantee certain SLAs around availability, performance, etc. Outside of Azure, Microsoft does not own any infra or the networking or computing or storage or any of these parts of the infrastructure. So depending on the provider, either the customer owns these or the provider owns these pieces of the infrastructure. Microsoft only provides a software that runs on top of this infrastructure. Hence, there are no guarantees on SLAs. It's a joint responsibility here. Moving on to the next slide. Let's go a bit deeper into Azure Arc Data Services and how it works under the hood. I have some animation, so let me fill up the slide here. Okay, I think that's about it. So what I have here is the architecture diagram of Azure Arc Data Services. In the previous slides, I mentioned that Arc Data Services is a PaaS-like solution and has a lot of built-in capabilities such as HA, DR, automatic backups, monitoring, logging, etc., regardless of where you run. The question then is, how are we able to provide these capabilities consistently across the different infrastructures? The key to this design is the use of Kubernetes as a layer of abstraction of your underlying hardware. Arc Data Services runs on top of Kubernetes and interacts directly and only with Kube APIs. And Kubernetes takes care of everything below it. So let's read this slide from the bottom up. First, you bring your own infrastructure. There are no requirements on providers or how much capacity you need to bring. Depending on the workload that runs on top of this infrastructure, you bring whatever is needed by your application, whether it's CPU or storage or memory, etc. Then you install your favorite Kubernetes distribution. We support any CNCF certified Kubernetes distribution. This includes your native Kubernetes, Red Hat OpenShift, Rancher, EKS, GCP, AKS, Azure Stack HCI, any of these Kubernetes distributions. Then you install Azure Arc enabled data services. This includes two components. First, Azure Arc Data Controller and the actual database engine itself, which could either be SQLMI or PostgreSQL. The Azure Arc Data Controller is a Kubernetes-based operator, and this operator brings with it all the built-in capabilities that we have been talking about. Whether it's provisioning, deprovisioning, monitoring, logging, automatic backups, all of these things are managed by this Azure Arc Data Controller. Once you install the data controller, you install one or more SQL instances or PostgreSQL servers, and this data controller manages all these SQL instances. To deploy the Arc data services, you can use the same tools you already use today, such as Azure Portal, Azure CLI, or Azure Data Studio, or even kubectl, if you want to run in a kube-native way. The required container images can be pulled directly from MCR, Microsoft Container Registry, Or you can pull those images to your own local private repository first and then deploy from there. If you remember, in one of my previous slides, I also mentioned we support two connectivity modes. Let's look into that. So we have directly connected mode and indirectly connected mode. You decide the connectivity mode at the time of deployment, and this cannot be changed post-deployment. Direct connected mode means your Kubernetes cluster has direct and secure connection to Azure. Indirect connected mode means your Kubernetes cluster does not have any connection to Azure, and Azure has no knowledge of your environment. Probably you're running in isolated mode. Right? The fundamental and core benefits which I've been talking about until now, such as built-in backups, built-in HA, built-in DR, monitoring, logging, are all available in both the modes. In the direct connected mode, there are some additional advantages compared to the indirect mode. By nature of this connectivity between Azure and your Kubernetes cluster, you can run additional Azure services such as Azure Security, Azure Policy, Azure AD, etc. You can also optionally upload your logs and metrics from your cluster into Azure Monitor or Azure Log Analytics, etc. The other things, or one of the other things you can also do is you can deploy directly from Azure portal onto your Kubernetes cluster that's running outside of Azure. Let's move on to the next slide. Demos. So let me switch over to my demo environment and show you how to deploy an Azure-Arc data controller. Okay, so what you're looking at is Azure portal. I have a resource group called DPS 2022. And as you can see, I have two resources here. I have an AKS cluster, and I have another resource that says Kubernetes-Azure-Arc. In a normal, typical environment, this AKS cluster will be on premises, whichever distribution you're running, Red Hat or Rancher or one of those things. And when you project that Azure, the Kubernetes cluster into Azure, what you will see is this first row of type Kubernetes-Azure-Arc. So what I'm going to do now is to deploy data controller onto my Kubernetes cluster. So in the search bar, I'm going to search for data controller. And you will see that there's an Azure-Arc data controllers service. So I'm going to click on it and I'll say create, and it will pull up the first option. It asks me is whether I need to deploy this in a direct connected mode or indirect mode. In this case, we will deploy it in the direct connected mode, which is the default. So I'm going to choose next. So this is very typical Azure resource deployment screen. You have your subscription information, resource group, and then you move on to the data controller details. Things like what is the name of your data controller? What is the custom location where you want to deploy this? You can think of custom location as the namespace in your Kubernetes cluster. So custom location and namespace have a one-to-one relationship. So in this case, I can either create a new custom location or choose an existing one. And then finally, the Kubernetes configuration itself. So we have certain built-in templates for popular Kubernetes distributions, things like Azure-Arc OpenShift, kubeadm, GKE, EKS, OpenShift, or even Azure template files. So these template files have common settings like networking, CPU, storage, memory, where should the log files go, where should the data files go, etc. So you can choose an existing profile, or you can choose a custom template, and you'll see a blade that comes up on the right where you can provide your own information. You can also provide things like which repository should I pull the images from? Should I get them directly from MCR or should I get it from a local private repository? Once you provide all that information, you also need to provide the credentials for accessing your Grafana and Kibana dashboards. So if you remember, I mentioned you have built-in monitoring and built-in logging. This monitoring and logging is powered by visualizations from Grafana and Kibana dashboards. And you need a credentials to log into that. So that's what this metrics and logs dashboard is. So give me just a minute and I'm going to fill up all this information and we will proceed with deployment. Okay, so I've put in all the information. I'm using the resource group DPS 2022. I'm going to call my data controller DC-DPS 2022. I'm going to create a new custom location, DPS 2022 NS. NS is the namespace. I'm going to use the AKS premium storage template or profile because my Kubernetes cluster is currently running in Azure. It's an AKS cluster, so I'm going to use the AKS template. And I'm going to use the load balancer service type, and I've provided some credentials. So we'll go to next, which is the additional settings. So I have the option to automatically upload my metrics and logs. So in this case, I will upload the metrics but leave the logs out of it. So just go to tags, fill in some values. I'm going to do a quick validation, and then I will proceed to deployment. So my deployment is in progress. While the deployment is happening, I can also show you how to create the data controller from Azure Data Studio. So in Azure Data Studio, if you go to extensions, we have an extension called Azure-Arc that you want to get. Once you install the extension, that extension brings with it the capabilities of deploying and managing your Arc services. So I can click on these three dots here at the top left and go to new deployment and select Azure-Arc Data Controller. Click on select, and what it does is it will go and try to detect my existing Kubernetes cluster connections. We can ignore these errors here. It also checks if I have kubectl and Azure CLI installed, and checks the minimum versions. I can go to next. It reads from my kube.config context, and it asks me what connectivity mode I should deploy this in, just like in Azure portal. If I say direct, and I can browse, select the kube.config file if it is not in the default location. Right now, the default context is DPS 2022 AKS, which is selected. I can also change it to something else if I want to. I think my other clusters are not Arc enabled. That's why this is disabled right now. Again, just like in Azure portal, you can choose which profile you want to use. Go to next. I can sign in, provide my Azure connection information, resource group, location information, and then let me complete this information. So it looks like my Azure Data Studio has some connection issues. It's not populating my subscriptions. So we'll switch over to CLI. In CLI, we have an extension called Arc Data Extension that you need to install using AZ extension add. And with this Arc Data Extension, you can create and manage Arc Data resources. So you can do AZ Arc Data DC create, and you can provide all the parameters that we provided in the Azure portal, and you can deploy the data controller either in the direct connected mode or in the indirect connected mode. So let's go back to the presentation, and we'll come and check the status of the deployment in just a second. Okay, so let's move on to the next topic. So now that we have Arc Data Controller deployment going on, the next topic is one of the database engines that's available in Arc Data Services, which is the SQL Managed Instance. So what I have here is a matrix format of comparing the SQL Server in different deployment models. So on the leftmost column, I have the most common enterprise features that most customers typically use. And in the comparison matrix, I have SQL Server on-premises that you typically have today. The second column is the Arc SQL Managed Instance that we are talking about today, which you install on a Kubernetes cluster. The third column is the Azure SQL MI that runs in Azure. As you can see here, pretty much all of the SQL engine features are available in all the three deployment models. So the point here is that Arc SQL MI is the same SQL Server that you already use today, whether it's SQL Server or Azure SQL MI. In the same format, in the next slide, we are comparing the management capabilities across the same three deployment models. Again, on the leftmost column, I have all the management capabilities such as HA, DR, monitoring, patching, backup restore, etc. And the first column is the SQL Server that you have on premises. The second column is the Arc SQL MI, and the third column is the Azure SQL MI. As you can see, there are significant differences here. For instance, When you have a SQL Server on premises, you need to manually set up HA and DR and backup jobs for all those databases, custom monitoring scripts, or even use third-party solutions for some of these capabilities. In Azure, when you deploy the SQL MI, you get all these benefits built into the service, which is the PaaS model, right? You just decide what capabilities to use and which ones to not to use. When it comes to Arc SQL MI, in it's a hybrid model, there is a joint responsibility between customer and Microsoft. We provide the software that has these management capabilities built in, just like in Azure, whether it's HA, DR, backups, monitoring, logging, etc. And you, as the customer, you bring the infrastructure that is needed to support these management capabilities. One thing to note here is that in Azure, Microsoft owns the entire stack from hardware to software and everything in between. So we have guarantees on SLAs SLAs around availability, performance, etc. In Arc SQL MI, we don't have any control on the infrastructure. We operate above the Kubernetes layer. As such, there are no guarantees on SLAs or performance. You, as the customer, you bring whatever hardware you want that meets the availability and performance requirements of the applications that is going to be hosted on Arc SQL MI. Moving on to service tiers. Azure-Arc Data Service is an Azure branded service with billing similar to what we have in Azure. Hence, we have two service tiers for Azure-Arc Data Services. One is general purpose, the other one is business critical. As I mentioned in earlier slides, many of the core capabilities are available in both the service tiers, things such as provisioning, deprovisioning, built-in monitoring, built-in logging, DR, automatic backups, etc. Where you start seeing differences is the highlighted sections, things such as CPU memory, limits, high availability, etc. You can think of general purpose service tier as equivalent to the standard edition in your on-premises world. This means there is a limit on the CPU and memory that you can assign to the SQL Server instance. Also, the feature set is limited to the what you have in the standard edition. Business critical is equivalent to the enterprise edition. So there is no limit on compute capacity and you can use all the enterprise features. Another differentiator is in the area of high availability. Business critical has significantly higher level of resilience for availability, upgrades, read, scale out, etc. We'll go into a lot more details into each of these features in the next session. The next topic is the business continuity. I think we covered briefly some of these in the previous slide, and we'll cover these in detail in the next session. Okay, demo time again. So let's go ahead and deploy a SQL Managed Instance from Azure portal. Before that, I'm going to go and verify the Arc data controller, make sure it's deployed, and then we'll go to the Azure portal and deploy the SQL Managed Instance. Okay, so going back to my demo machine again, and I'm back in my resource group. I can see that there are two new resources now. There is a custom location that got created, and there is also a Arc data controller that got created in the last few minutes. So I said custom location is similar to your namespace. It is mapped one-to-one, and Azure Arc data controller is also deployed. So what we can do is go to my command prompt here, and I'm going to run a kubectl get data controllers dash capital A. It's going to list all the data controllers in my cluster. In this case, I have DC dash DPS 2022. This is what we just deployed. And this data controller is in the namespace DPS 2022 NS. So what we do now is go and deploy a SQL managed instance from the Azure portal. So I'm going to go here, and in the search bar, I can type SQL managed instance. And you will see two results for that. There is a SQL managed instance, which is the Azure SQL MI. There is a SQL managed instance dash Azure Arc, which is what we want. This is the Arc SQL. I'm going to select that, and I'll say create, and I will get a similar resource create screen. Let me fill out all these options here. So I've started putting in information. I'm going to use the same resource group, same subscription, And I'm going to use SQL MI1 as the name of my instance. And for custom location, which is the namespace where I want to deploy the SQL MI, I'm going to use the existing custom location that we already created for data controller. And the service type is either load balancer or node port. I'm going to use load balancer because it gives better resiliency. And then one important thing to note is make sure you click on this configure compute and storage option and go through the options here. So just like in Azure SQL MI, we have the two service tiers, general purpose and business critical. I'm going to create a business critical service tier, and I'm going to select development only for now. And I have the option to deploy either one replica, two replicas, or three replicas because this is a business critical. If I choose general purpose, I only get one replica. So depending on your availability requirements, you can either go for general purpose or business critical. And readable secondaries. This is another feature that's only in the business critical service tier. If you have more than one replica, you can offload your read workloads to one of the secondaries. Number of secondaries to be synchronized for write commits. That's where you choose this option. And then I can provide CPU and memory, how much I want to allocate to each of these instances. And also, what are the storage classes where my data should go to, where should my logs go to, which storage class should my backups go to. One thing I'll point out here is that for backups, the storage class should be read-write many capable. That's a requirement for both the service tiers. And I'm going to fill out all this information and click on deployment. I'm going to change one more thing here to save on some compute. Say apply. I'll provide the credentials here. This is my SQL authentication credentials. And we don't want ID authentication right now. It's going to do a quick validation and then we will proceed with deployment. Looks like my validation passed, so I'm going to click create. Then you will see the deployment progress. So let's give this a minute. Let's finish it, and during this time, we'll come back to the slides. Okay, so we're back on the presentation. So let's move on. The next topic in this session is the total cost of ownership. Now, Arc Data Services is a brand new offering from Microsoft in the hybrid space. And consuming this service, especially in the Arc SQL MI, requires setting up new infrastructure and migrating to it. So naturally, the business stakeholders would want to know what is the TCO. Am I going to save cost? Is it going to cost me more than what I'm currently incurring, etc.? So what I have here is a rough back of the envelope type of scenarios to give you an idea of how to think about for TCO. So on the left, you have your existing workloads. Think of SQL servers running in a VM or a physical host. And we will read this slide from the bottom up. Let me go back here. So you have your hardware that you provisioned to run this SQL server. First, you install your OS, whether it's Windows or Linux as your host operating system. Then many customers these days have some sort of virtualization software to optimize the infrastructure, whether it's Hyper-V or VMware or some other virtualization software. Then you install the SQL server on the host, right, in the VM, for example. After that, you set up all the management activities, right? Things like backup, monitoring, availability, disaster recovery. You may be using your own homegrown scripts or even potentially third-party software for some of these management activities. Right? And finally, you have the people who manage this entire stack. Now let's see how the stack looks like in the Arc Data Services model. Again, reading from the bottom up. First, you still need the infrastructure with appropriate CPU, memory, storage that's needed for your workload. Then the host OS needed to deploy the SQL server. Now, Arc Data Services, as I mentioned before, it runs on Kubernetes. And you can install Kubernetes bare metal. So the host OS component becomes optional here. This could be a potential for cost saving. Next, you have the virtualization layer. Again, you have the option to go with bare metal here and potentially save some costs. Next, you need Kubernetes to run the Arc data services. Now, this is a net new cost for you if you go with something like Red Hat OpenShift or Rancher or some of these providers, right? You could also go bare metal and save cost if you want to. Then you install the Arc data services, which includes the data controller and one or more SQL managed instances. There is no cost to the data controller. We only charge for the SQL instances that run on top of the data controller, and we only charge for the CPUs consumed. There is no charge for storage or memory or any other part of it. There are two line item costs here, right? There is a SQL licensing and there is a SQL manageability IP cost. The manageability IP cost includes all the management capabilities that are provided built in. Now, since you get these management capabilities built in, you could potentially eliminate most of the third-party software you have, such as any backup software or any monitoring tools to save on costs over there. Finally, you still need the people who are managing this stack. There's no change there. We haven't been replaced by bots yet. The takeaway in this slide is that this new model here, there is an opportunity to save costs in some parts of the stack, and there is a potential for new costs in other areas. Overall, the expectation is that there is a significant cost saving in the long run, as some of the mundane DBA tasks can be automated and people can do more productive things here. So moving on, let's talk about roadmap. Before we get to the roadmap, let's check what is the status of our SQL MI deployment. So checking on the status of the deployment for Arc SQL MI, my Azure portal says deployment is complete. I can go back to the resource group and I should see that there is a new resource now called SQL Managed Instance Azure-Arc. I can click on this and see all the properties. It's in Azure information, which resource group it is in, what is the subscription, things like that. And what is the data controller that's managing this SQL MI? What is the custom location or the namespace? These two are one-to-one. What is the external listener endpoint that I can use to connect to the SQL instance? Current status of the SQL MI and whether I'm using Active Directory or not. There are also additional options here, like I can go to upgrade management and see if there is a new release available, so I can upgrade to it. Right now it says I'm on the most latest version. You can see that the current version is v1.9 and there is a timestamp here. It says 7-12. We just had a release this month. We have monthly releases. We align to the patch Tuesday so that there is less upgrade work for customers to do. So the image here is the latest one that we released last week. Going back to the overview here, and let's flip over to the command line and check on my cube SQL instances here. I can run kubectl get SQL MI and do capital-A. This gives me a list of all the SQL instances. Again, same information. SQL MI1 is what we deployed just now. It tells me there are 3 replicas and the status is ready. And the namespace where the SQL instance is running, in this case, it's the same namespace as the data controller. We don't support multi-namespace yet. So today, all your data controller and however many SQL instances or SQL servers you have, they should all be in the same namespace. I also have a primary endpoint that I can use to connect to. So for example, I can use this and connect to it from whether SQL Management Studio or even Azure Data Studio. So let's say I cancel out of this and have my connections here. I can add a connection and provide the endpoint here. I'm going to use SQL authentication and I will use the same credentials that I used or that I provided when I'm deploying the SQL MI from portal. So let's say connect, and I've connected to that SQL instance. So this is the Arc SQL MI instance that we just deployed. So let me run a new query on this instance. Let's say select, increase the font size here. If I run add that version, expand expand it, it should say Azure SQL Managed Instance dash Azure-Arc. So it looks like we have a successful deployment of Arc SQL MI. Let's also look at the high availability section. For that, I'll flip to SQL Managed Instance, the SQL Server Management Studio, where I can see all the nodes and availability status for each of those nodes. Okay, so we were going to look at the SSMS, connect to the SQL instance and look at the availability groups. I'm having an issue launching SSMS. I probably have an insider build that is preventing me from launching SSMS. So instead, we can continue to use Azure Data Studio. So I have the connection to my SQL instance, and I'm going to run a few queries to look at the contained availability groups. For example, select star from sys.availability groups. So if I run this command, it should tell me there's one availability group. I think there's another command. It's here. There's one column that says is contained. Right now it says yes. So this is a contained availability group. We can also do availability replicas instead of groups to see how many replicas we have. So you can see that when I deployed in the Azure portal, I selected 3 replicas under high availability business critical service tier. So you can see that there are 3 replicas here, and SQL MI-0, 1 and 2. These are the 3 pods, if you will, and the endpoints for each of those. They're all available. They're in synchronous commit mode. What else? I think those are the properties. They're automatic seeding. So we can also look at the pods in the kubectl. Let me connect to my PowerShell here. If I run kubectl get ns, I'll see a list of all the namespaces in my cluster, and I'm going to run kubectl get pods -n, and I'm going to use the namespace where my SQL MI is, in this case DPS 2022 NS. So what I'm going to see is a list of all the pods that are inside this namespace. So the first set of pods are belong to the data controller. Like we have a bootstrapper, we have a data controller related services. Then we have a couple of pods for log, one for database and one for the UX or UI, the Kibana dashboard, and then metrics service, and then one service for each of the nodes that I have. I have 3 nodes in my Kubernetes cluster, so I'll see 3 pods, one for each node. And then I also have a UI, one pod for running the UI, which is the Grafana dashboard. And then finally, the SQL instances. So you can see that I have SQL MI-0, which is one pod, 2, 0, 1, and 2. These are the 3 pods. Each of these pods is running one instance of SQL Server. And there is also a SQL MI HA pod. This is the orchestrator pod that manages the failover between the instances. So we'll talk about the orchestrator pod in the second session. So with that, let's switch back to the roadmap. Okay, so this is the final topic for today's session. Everything we discussed today is publicly available. There we go. So we have Azure-Arc enabled servers, Azure-Arc enabled SQL Server, Azure-Arc enabled Kubernetes, Azure-Arc enabled SQL MI. So all of these services are publicly available, both general purpose and the business critical service tiers, which means you can run production workloads on these services. We also, under the Azure-Arc brand or umbrella of offerings, we also have the other offerings like Azure-Arc enabled management services. We have Azure-Arc enabled app services. Some of them are still in preview, but there's also some that are publicly available. When it comes to preview, for Arc enabled data services, we still have Postgres that is in preview. And you can also see that under infrastructure, we have a few additional services that we are offering as a preview version. Just focusing on SQL MI again. Like I said, the GP and BC service tiers are fully generally available. All the features we talked about, automatic backups, HA, DR, built-in monitoring, logging, all of these are generally available, all these services. The connectivity modes, direct and indirect, is also generally available. Azure Monitor integration. In the direct connected mode, you can optionally upload your metrics and logs to Azure Monitor and Azure Log Analytics. That feature is available. Contained availability groups for HA. We'll talk about this in more detail in session 2. And we also have Azure Instance Failover Groups, which is what the DR feature is. We'll talk about that again in the second session. Things that are in preview are AD, Active Directory, for Arc SQL MI. So we support both the authentication modes, SQL authentication and AD authentication. AD is still in preview, and under AD we have both system managed key as well as customer managed key, and that whole AD authentication piece is still in preview. Also, the other database engine, Azure-Arc enabled PostgreSQL Server, is also in preview. So look forward to those services becoming generally available. I think that's about what we have for today. So I also have a bunch of resources here for you to go and try. There's few videos, there's blogs, there's jumpstart scenarios where you can go and quickly implement or get up and running quickly. We have documentation, there's some blogs, so a whole lot of resources for you to go and get more information, get familiar with Arc data services, and get started on those things. So with that, thank you for joining the attending. I hope you have a fantastic rest of your conference. Just remember, we have a session 2 coming up that will have a lot more details, in-depth demos on each of these built-in capabilities that we were talking about. Thanks, everyone. Bye.